Assalamualaikum. Hello everyone. Have you ever wondered how scientists can identify a substance without even saying its molecular structure?
Huh?
One powerful technique used to do this is infrared or IR spectroscopy,
Commonly known as IR spectroscopy.
However, before obtaining accurate result, the sample must be prepared correctly. Infrared spectroscopy is an analytical technique used to identify chemical compounds by measuring how molecules absorb infrared radiation.
This analytical technique is widely used to identify chemical compounds by studying how molecules absorb infrared radiation.
In this video, we will discuss 3 common sample preparation techniques. First, the KBR pellet method, ATR, and the thin film method. Stay tuned for the next session.
Infrared spectroscopy is an analytical technique used to identify and study chemical compounds. It works by passing infrared light through a sample and measuring which wavelengths are absorbed. Different chemical bonds absorb specific frequencies of infrared radiation, causing molecular vibration. These absorptions produce a unique fingerprint which helps identify functional groups and determine the structure of the compound.
Now, let's discuss the key principle behind the sample preparation in IR spectroscopy.
At its core, almost all IR techniques rely on one fundamental rule. Infrared light must either pass directly through or interact precisely with your sample to produce an accurate spectrum. Here lies the challenge. If your sample is too thick or completely undiluted, it blocks the beam. Too much IR radiation gets absorbed, resulting in massive, flat-line peaks and completely unreadable data. To solve this, we must manipulate the sample's thickness and concentration. That is exactly why we use specialized preparation methods. Whether we are casting polymers into ultra-thin films, diluting solid powder into transparent KBR pellets, or pressing sample onto an ATR crystal for shallow surface reflection. Every method shares the same goal.
We are optimizing how light interacts with matter to ensure we capture crisp, reliable, and scientifically accurate spectral data.
So I will explain the real-life application of sample preparation technique in IR spectroscopy. First, the KBR pellet method is widely used in the pharmaceutical industry. The scientists mix powder drug sample with potassium, bromide, and press them into a pellet for analysis. And this helps identify active ingredients and verify the purity of medicine. Second, the ATR or attenuated total reflectance is commonly used in forensic science because it requires very little sample preparation. Investigators use ATR, FTIR to identify unknown substances such as drugs, fibers, and plant samples collected from crime scenes. And the last one is thin film method. Thin film method is important in the polymer and electronics industry. It is used to analyze plastic packaging materials and protective coating on electronic devices to ensure product quality and performance.
In conclusion, sample preparation is a critical step in IR spectroscopy. We choose different methods like KBR pellet for solid or thin film for liquid based entirely on the sample type and what we need to analyze. Ultimately, understanding this technique is in preventing light blocking or scattering, which directly improve accuracy and ensure a much better interpretation of our IR spectra.
Infrared radiation is produced by the IR source. A common IR source used in IR spectroscopy is the global source. The infrared beam is directed towards the sample for analysis when the infrared light interacts with the sample. Certain wavelengths are absorbed by the molecules. This causes molecular vibrations such as stretching and bending. The infrared radiation that is not absorbed passes through the sample and reaches the detector. Next is signal processing. The detector converts the infrared signal into the electrical data, which is the process by the computer. spectrum. Finally, the software generates an infrared spectrum showing the absorbance of different wavelengths. In conclusion, IR spectroscopy works by passing infrared radiation through a sample and measuring which wavelengths are absorbed. The resulting spectrums helps identify functional groups and provide information about the molecular structures of the samples. Thank you.
I just had to let you know you're